We're looking today at the first two sections of Chapter 6, first 6.1. So if you'll open your packet to 6.1, you'll find the vocabulary nth root of a. So the way that that's written is n, which is the index, goes right inside the little radical. And that is the same thing as writing a to the 1 over n. So this is actually that last row on your laws of exponents sheet that I gave you, that I said you don't need to understand this yet. Well, now is the time. So an example, for example, cube root of 27, which is the same thing as writing 27 to the 1/3. So you're trying to think of what number, when I raise it to the third power, do I get 27? Well, that would be 3. Or another example, fifth root of 32. And another way of writing that would be 32 to the 1/5. So you're thinking, what number, when I raise it to the 5th power, do I get 32? And that's 2. And this is why it's so important to memorize your powers, because you need to know 2 to the 5th is 32. 3 to the 4th is 81, so that means the 4th root of 81 is 3. And again, to reiterate, another way of writing 4th root of 81 would be 81 to the 1/4. Now, when we have a square root, so like square root of 16, it's always been an understood 2 there. We just never write it. In the square root of 16, you're thinking, what number to the 2nd power gives me 16? Or in other words, 16 to what power, or I'm sorry, 16 to the 1/2. And so square root of 16 is 4. Now, if you scoot down a little bit on your notes, you'll see a section called rational exponents, and it defines a to the m over n being essentially the nth root of a to the m. So what this means is that n is your root, or the index, and m is the power. And if the exponent is negative, that just means that all of this is happening in the denominator. So this means 1 over the nth root of a to the m. So let's look at some examples of that. On number 1, we're asked to find the 4th root of 16. So what number to the 4th power gives me 16? And you can pause the video if you want to think about it for a second. So what number to the 4th power gives me 16? Well, that's 2. I just did that one up at the top. Second problem. This is asking for the square root of -49. Well, we're not going to consider imaginary numbers in this chapter, so this is non-real. And in fact, any even root of a negative number is going to be non-real. 4th root of -49 would be non-real. Number 3, the cube root of -125. Now, we can take odd roots of negative numbers because you're trying to think, what number to the 3rd power gives me -125? Well, that would be -5, because -5 times -5 times -5 is -125. Number 4, the 5th root of 243. So what number to the 5th power gives me 243? That's 3, because 3 to the 5th is 243. And again, memorize those powers. Numbers 5 through 8 now bring in the idea of, a number to the m over n. So remember that the numerator is your power, the denominator is your root. So on number 5, this is the square root of 4 raised to the 5th power. Square root of 4 raised to the 5th power. So you take the square root of 4, that's 2. So now we're looking at 2 to the 5th power, which is 32. Number 6, remember the negative exponent just puts this in the denominator. So this is 1 over 9 to the positive 1/2. 9 to the 1/2 power means square root of 9. Square root of 9 is 3, so this is 1/3. Number 7, 4th root of 81 to the 3rd power. So the 4th root of 81 is 3. So we're looking at 3 to the 3rd power, which is 27. And number 8, 8th root of 1 to the 7th. Well, any root of 1, the 8th root of 1, the 9th root of 1, the 12th root of 1 is 1. So we're looking at 1 to the 7th, which is 1. Numbers 9 through 12, you're told to do in the calculator and round when necessary. So you want to put these in the calculator exactly as you see them. Okay, so 9 and 10, I've just put to the calculator. So 6 to the 2/5 is about 2.05. 64 to the negative 2/3, that's an exact number, so we don't need to round. So 0.0625. So 6 to the 2/5 is about 2.05. And 64 to the negative 2/3 is 0.0625. And since we got an exact number there, that means that this is something that we could find, in our heads. This is 1 over 64 to the 2/3, so the cube root of 64 squared. Well, the cube root of 64 is 4. So 4 squared is 16, so this is 1/16. Okay, but they wanted us to do these in the calculator, so there's those. So these next two problems are written in radical form, and of course you could put them in the calculator as a fractional exponent, like number 11, you could type it in as 16 to the 5/4. Let's go ahead and type it in though exactly as we see it. So I want to put in parentheses, and then the way to get the 4th root, you do math 5. So I want to put in the 4th root of 16, and then I'm going to close my parentheses, raise that to the 5th power, 32. So this is also one that we could have done without a calculator, because the 4th root of 16 is 2. 2 to the 5th is 32. Okay, number 12, the cube root of negative 30, and then this is in parentheses, squared. Okay, so this time, now cube root has its own special button, so that's math 4. So the cube root of negative 30, come outside of the radical, close your parentheses, and then we're going to square it. So we know this number is going to be positive because anything squared should be positive. So it's about 9.65. Looking at 13 through 16, now we're solving equations. And so remember that when you're solving an equation, if it's an even power, so like here, you're going to need to do the plus or minus. With odd powers, you don't have to worry about that. So looking at number 13, the first thing that we want to do is divide by 8. So we would have x cubed equals 8. And then how do we undo a cube? We take a cube root of both sides. So the cube root of x cubed is x, cube root of 8 is 2. Okay, look at number 14. The first thing we need to do is multiply both sides by 2. So 2 times 1/2, 5/12 times 2. So this gives me x to the 5th equals 1024. So I take a 5th root. So x equals 4. Number 15, on this one, the first thing I need to do is take a 4th root of both sides. Now remember, I'm taking an even root, so I'm going to have to do a plus or minus, just like we did with square roots in equations. So over here, the 4th root and the power of 4 basically cancel, so I have x plus 5 equals the 4th root of 16 is plus or minus 2. So now I want to subtract 5 from both sides. So x equals -5 plus or minus 2. So this could be -5 plus 2, which is -3, or -5 minus 2, which is -7. And then over here, on 16, we want to take the cube root of both sides. So we have x minus 2 equals, so the cube root of -14, I'm going to come over to my calculator for that because -14 is not a perfect cube. So I need to do the cube root of -14, which is about -2.41. So I need to add 2 to both sides. So I'm adding 2, and then I have minus 2.41 here, -2.41. Remember, I'm not doing a plus or minus because this is an odd root. We only do that with even roots. So 2 minus 2.41, so x is about 0.41. So number 16 is a word problem. It says a hospital purchases an ultrasound machine for $50,000. The hospital expects the useful life of the machine to be 10 years, at which time its value will have depreciated to $8,000. Depreciated means like going down in value. The hospital uses the declining balances method for depreciation, so the annual depreciation rate, R, in decimal form, is given by this formula. In the formula, N is the useful life of the item in years. Well, in the problem, they tell us that N is 10 years. S is the salvage value, so like what it's going to be worth in 10 years. $8,000. C is the original cost. Well, they bought it for $50,000. And we're looking for the annual depreciation rate. So we're looking for R, and they've told us R is going to be in decimal form. So we can expect a decimal that will convert to a percentage. So this problem is really a matter of plugging these things in correctly and then putting it in the calculator. So I'm going to have 1 minus 8,000 over 50,000 raised to the 1/10, and this should give me R. So I plug that in to the calculator. So I have, I'm just going to type it in just like I see it. 1 minus 8,000 divided by 50,000 raised to the 1/10. So I get about 0.17, which percentage-wise, so 0.17, if I convert that to a percent, I move the decimal twice to the right, so it's about 17%. So that means the ultrasound machine is declining in value about 17% per year.